The MMC all-wheel drive system is designed to automatically distribute torque to the vehicle's front and rear axles. Under slippery conditions and during acceleration, all-wheel drive offers traction that is superior to that obtained with a conventional two-wheel drive system. To distribute torque, all-wheel drive uses a center differential along with a viscous coupling in the transaxle. A transfer assembly relays torque to the rear axle, which may be equipped with another viscous coupling to limit slip between the rear wheels. Welcome to this month's Master Tech. In this month's program, we'll examine the all-wheel drive system as it occurs on the Stealth, Laser, and the redesigned Vista wagon. The viscous coupling type all-wheel drive system first appeared on the 1989 Dodge Colt wagon. For 1992, the all-wheel drive system is used on Dodge Stealth RT Turbo. On Stealth, the system features a Getrag 5-speed manual transaxle and a limited-slip rear differential. The Laser RS Turbo all-wheel drive model uses a 5-speed manual transaxle. A limited-slip rear differential is standard except on vehicles with anti-lock brakes. On the Plymouth Vista, all-wheel drive is used with both the 1.8 and 2.4-liter engines and is available with both the 5-speed manual transaxle and the 4-speed automatic. A limited-slip rear differential is available as an option. In general, the all-wheel drive system operates in basically the same way on Stealth, Laser, and Vista. A transfer gear on automatics or intermediate gear on manual transaxles relays power to the center differential. The center differential then relays power to the front and rear axles. To prevent all of the engine's torque from being sent to an axle whose wheels are slipping, a viscous coupling is installed between axles. The viscous coupling consists of inner and outer plates which are surrounded by silicone oil. Because of the force required to shear the oil in the coupling, the plates tend to turn at the same speed. As a result, as one set of plates in the viscous coupling increases in speed due to slippage at the front or rear wheels, the other set of plates begins to receive torque from the resistance of the silicone. This torque is transmitted to the wheels on the other axle. In case of extreme speed differences between plates, the silicone oil heats up and the plates turn together as a unit. This is known as the hump mode. On a Laser equipped with a manual transaxle, the inner plates of the viscous coupling are splined to the coupling hub, which in turn is splined to the center differential case. This arrangement provides a connection to the front axle. The outer plates are splined to the viscous coupling housing, which is splined to the center shaft. This provides a connection to the rear axle. The way in which the viscous coupling is connected into the all-wheel drive system depends on the type of transaxle the vehicle has. The arrangement we looked at for the Laser manual transaxle is the same as that used for Vista, equipped with a manual transaxle. On the Stealth, the center differential uses a planetary gear set. The sun gear serves as a connection between the inner plates of the viscous coupling and the front output shaft. The carrier serves as a connection between the outer plates of the viscous coupling and center shaft, which provides power to the rear axle. On Vista Automatic, the viscous coupling arrangement is somewhat different. The inner plates of the viscous coupling link the coupling to the center differential. The outer plates link the coupling to the front output shaft. On all vehicles, power for the front wheels proceeds from the center differential and viscous coupling to the front differential. Power for the rear wheels proceeds from the center differential and viscous coupling to the transfer assembly. The transfer assembly uses a set of beveled gears to change the direction of power 90 degrees and to relay power to the propeller shaft. All vehicles use a three-piece, four-joint propeller shaft. To compensate for changes in angle and length in the prop shaft pieces, the propeller shaft has a component called the lowbrow joint. The lowbrow joint uses caged balls to connect the grooves in the inner and outer races of the joint. The grooves are at an angle to one another, allowing for changes in angle or length on either side of the joint. The rear axles on Laser equipped with ABS and on Vista without the limited slip option use conventional differentials to allow for speed differences between the right and left rear wheels. Laser models not equipped with ABS and Stealth feature a limited slip rear differential, which makes use of a viscous coupling. Vista has an optional limited slip rear differential. The viscous coupling is identical in operation to the one in the transaxle described earlier. In this case, however, the viscous coupling inner plates are connected to the right-hand rear drive shaft and the outer plates are connected to the left-hand rear drive shaft. When one of the rear wheels starts to slip, the tendency of the viscous coupling to minimize speed differences between the plates causes a transfer of torque from one rear drive shaft to the other. Here, the coupling is transferring torque from the left rear to the right rear drive shaft. As in the transaxle viscous coupling, when speed differences heat up the silicone fluid, the rear axle viscous coupling plates are forced to turn together. This is the hump mode we referred to earlier. When this occurs at low speed in a tight turn, an all-wheel drive vehicle may exhibit characteristics similar to those of a four-wheel drive vehicle. This is normal. The viscous coupling is a sealed unit. As a result, you do not need to check the level of silicone oil or add to it. However, you do need to check the level of the lubricants used in the transaxles, transfer assemblies, and rear axles we looked at. That and lubricant types are the subject of the next part of this program. One important thing to remember in checking fluid levels on MMC all-wheel drive systems is that the vehicle must be level. Another is that the transaxles and transfer assemblies have separate sumps and must be checked separately. On Stealth, the transaxle filler plug is located on the side of the transaxle case facing the front of the car. The fluid should be level with the bottom edge of the filler hole. The drain plug is located at the bottom of the case. The filler plug for the transfer assembly on the Stealth is located on the front face of the assembly. The fluid level should be within a ½ inch of the bottom of the filler hole. The drain plug for the transfer assembly is located at the rear of the assembly on the bottom. On Laser and Vista wagon manual transaxles, the fill plugs are also located on the transaxle case facing the front of the vehicle. The fluid level should be within ½ inch of the bottom of the filler hole. The drain plug is located at the bottom of the transaxle on the same side as the filler plug. The filler and drain plugs on Laser and Vista transfer assemblies are in the same location as on Stealth. And as on Stealth, the fluid should be within a ½ inch of the bottom of the filler hole. To replenish or refill the Stealth, Laser, or Vista manual transaxles and all of the transfer assemblies, use 75W90 Mopar high-point gear lubricant. If you do use a substitute, make sure it